G'day all. The last couple of months I've had numerous inquiries if I would be able to take the time to explain how these super burners work and what the steps are to make one. So I hope I can get across in this video how they work and what they're used for. As you'll see, most metho spirit burners have a breather tube, a breather hole on the filler cap. These super burners, you don't have a hole on the filling cap, and to construct one, what you need the body, copper or brass, anything that you've got hanging around, and you need fiberglass wick for these. You can't use a cloth, cotton or anything else because it will eventually burn out and you won't be able to replace it. The fiberglass wick lasts forever. What you need to do is start off in here, coil the fiberglass wick in here, bring it, before you solder the copper tube, bring the fiberglass wick through your copper tube, down and out. Cut the fiberglass wick here, crimp that very hard, and then silver braze that. You can't just soft solder there, you need to silver braze that one. Then you drill a millimeter, whatever you do, drill a bloody half-inch hole, which is pretty obvious you can't. It's a 1/2 millimeter hole. It's got to be a very fine hole, just on the, about, you might be able to see that's about 5 mils back. Then you bend that curve in there and you aim that hole at the copper. So the idea is that flame aims at the copper and it preheats the methylated spirits coming along there and vaporizes it, and that's what causes the super burner to have that roaring noise. So I'll just light them up. I'm going to turn the light off and I'll just show you how they work. So there's a bit of a spill there, but you'll see that spill was from me. Wait for that to burn off. So ignore that spill. Now you've got the super burner working. Now I'll turn the light back on for a sec. So what's happening is that's blowing out of that hole and it's vaporized because it's heating up that part of the copper. So the methylated spirits is getting absorbed along the fiberglass wick, getting superheated here, turning into a vapor and emitting there in a vapor. So I'll just turn that off. You can hear that roaring. That's how the super burner works. Blow that one out and I'll light this one. So you'll hear it start to vaporize that metho. Straight away, now it's vaporized and you can hear that roaring. This is a smaller model, holds a little bit less metho. Now the heat that these put out is a lot more than one of these, a lot more. And there we have it, the super burner. Honestly, it's about an hour or so to make one of them, and they're just a different burner for different applications. Straight away you'll see this will jump across in a minute as soon as it gets hot. There we go, jumped over as the methylated spirits gets vaporized and you can hear it roaring. Can't see it with the light on, but you can still hear it. Okay, that's how the super burner works. So again, get your copper pipe, feed your fiberglass wick material right through both ends, have this end coiled out, so you've got a fair bit in here to soak up the methylated spirits because it goes through some metho. Once you've got that coiled in there, solder this part, crimp that off really hard, cut your fiberglass wick material there, cut that, crimp it hard, silver braze it, drill a 1/2 millimetre hole in there, bend this, have the jet aimed at that curve, you can see that curve, just move this out of the way, have that jet there aimed about that direction there, so the flame initially starts to get that copper hot. Once it gets hot enough, it'll vaporise the metho, and the metho will come down here in a vapour, get erupted, and it's just self-repeating, and it'll just keep going until your reservoir is empty. That's a smaller one. Again, no air holes. You've got it just works by suction. It'll as that's blowing out, it'll just keep sucking the metho through. No air holes. Once you've got this in a boiler, like in the firebox, because this gets hotter, it will really roar. So they're a hot boiler, a hot burner, a lot hotter than what you're used to. So keep an eye on it. Simple and effective super burners. So I hope that answers the queries that I've been getting, and have a go at making one. Really simple, and we'll put some water in the boiler. love this water tower that I made. Filling up. And already you can see it's just starting to come up. G'day guys, here's the little metho burner out of little steam engine kitten. I was interested to try and make a wick out of pumice stone. There's a bit of pumice stone, pretty roughly shaped. Take her in, line her up. There we go, turn the light off. Well, I reckon at a pinch pumice stone's alright. Bye now. I'll turn on the Jensen 20 steam engine, get that boiler coming back up to boil, and I'll show you how this computer fan can make some power quite easily to run these 8 LED lights. I'm really happy with this. It's pretty simple. If you search on YouTube for plans to convert a computer fan into a small generator, you'll find some step-by-step instructions that are quite easy to follow. If I can do it, and I don't know a lot about electricity and electronics, and it was quite easy for me, so I'm sure anyone can do it. I just turned up this small aluminium pulley, put it on the fan so it works, and I stippled this flywheel, which worked out perfect because you don't want a lot of tension on that. And on the watchmaker's belting, sorry, I was just doing something in the background then, you don't want a lot of tension on the watchmaker's belting, and that stippling is just enough to grip this really nice and stop any type of slippage. Okay, you'll see how this boiler's coming up. Yep, it's getting in nicely. Alright, turn the steam line on. Okay. Alright, there's the Jensen 20 going along nicely. Put the rocker switch on. There's some LED lights. Just looking through the back of the viewfinder on the camera, they look like they're flashing LEDs, but I think that's the camera picking them up. But the camera's it's doing about, I think it's set at 60 frames per second, so it's definitely picking up that little bit of a flicker. But in real life, those LEDs are not flickering. Off. Here's my iteration of a plasma ball run off a generator, which is run off a steam engine. It needed something called a bridge rectifier. The generator is AC. The plasma ball runs on DC. So in here under the switch is this little 4-pronged bridge rectifier, which I had never heard of before. Jan very kindly did me up a diagram, and I was able to follow that, and here we go. So thank you very much, much appreciated. I turned this aluminium insert in onto the base here, put a bit of brass around it, put the on and off switch on, made the brass bolts, did these two little brass uprisers, soldered them on, and I'm really happy with the way this looks. These generator, it's from Austria. I've got it hooked up to my Polish school engine. That's hooked up to the MSM 4-inch boiler. Black O-ring cord going to the new little Austrian Jenny, and we're off, lamp, so give it some steam, start her up. Okay, hit the on button, hit the lights, flip the switch off, switch on, alright. Okay, failure number 1. I'll be back in a sec. I will redo that steam line. Okay, that was fun. Okay, back again. Here we go with take 2. I want to get it down to a really nice try and slow that down a bit. Just wait till that engine burns through a little bit of that steam, uses up some of that steam, and you'll just want to get those hammers slower than that. Sounds very nice coming through the truss pot. I've gone this method. It's a bit of plate steel, 8mm, and some 8mm plate steel uprisers that I've brazed on, drilled them out. I've got to press these bearings in with some small ball bearings in there. Made this flywheel. Spins really easy in the ball bearings. Really nice. What my question, as I said, I've still got to press these bearings in. But this is what I've got so far. Pretty happy with it. It's got a lot more work to do on it. This is a transmission that I made on my lathe. It's really handy for reducing and increasing speeds, which is always something that's pretty difficult with these toy steam engines. Like, you're trying to run accessories and they'll either go too fast or too slow, engine hasn't got enough power, or it's got too much power. And this transmission is able to almost, I won't say indefinitely, but it's pretty close to being able to, you change the pulley over, you change the inner belt, and you can reduce or increase the speed to pretty much anything you want. So I've got the transmission belted up to the Jensen 20G, and then I've got it transmission belted up to this. It's a plastic model. It's modelled off, looks like a Stewart steam engine, and I've made some modifications to this. I've put it on this timber plinth, and I've made the brass spout on it so it directs the water into the reservoir, stopping it from splashing everywhere. And also, I'll lift this up. I took this wheel off when I was making it and put it on my lathe and turned a groove in the plastic so it takes a belt. Also, I've had a few queries about the belts that I'm using. These, if you look on eBay, type in PU belt. It's just, that's what it is. The Chinese call it PU belt, or watchmaker's lathe belt, and you'll find it comes in. I've got it in 4mm. What's this one? 3mm, 2mm. You can get it in heaps of different millimeters. It's really handy. If I don't use this, I'm usually using a black O-ring. This one, the PU belting is the one that you use a cigarette lighter, melt the two ends, stick it together. The black O-ring, you need a special super glue, plastic compatible super glue. That's the smallest one on there. Okay, I'll put the belt up to the next one. Going that little bit faster now. Go up to the next size. And again, it's going that little bit faster. Put that belt down to the slowest one again. On the transmission. So you can see how slow that pump's going now. So it's worked that transmission, that this wheel here is going fairly stiff rate. The steam valve is open full. That engine's going along at a really nice rate. The light's lit up on the generator, and that transmission has slowed that down. Like, just look at how slow that is moving. I'll just turn this down a bit. No, I'll turn it off just to stop the noise coming through the Steam Demon chuff pipe. But I think that was pretty good demonstration on just how slow these transmissions can slow any accessory that you want to run on a steam engine. They're just handy as a pocket on a shirt. G'day everyone. This is my Empire wannabe transmission that I've been working on over summer. I've finally got the green belting put on and going to give it its maiden few turns. Excuse my sniffing, I've got a really bad head cold. So presently I've got it on the big pulley going to the smallest pulley, so that should put some speed on this when I turn this. Yeah, I can hear that going. That's turning that fairly fast. Got a texture here. I'm going to try and put black mark on there. Put a black mark on the top of that. Hopefully that's getting picked up by the camera. So I'm going to turn this, and watching this, that's 1 revolution, 2 revolutions, 3 revolutions, 4 revolutions, nearly that's about 4 3/4 revolutions. For one turn of this, I get 4 3/4 revolutions of that one. So I'll move the belt up to the next pulley position, bring that around, and I'll count 1, 2. So I've got 2 for that one. So move this one to this one. Try this one. Line these up again. So it's 1 for 1. 1 revolution of this gives me 1 revolution of that. Okay, that's good to know. Move it up again to the next position. So it's 1 for this one, 2 for this one. 2 revolutions of this, 1 revolution of this one. Move it up to the next. Level them up. Okay, so we've got 1, 2, 3, 4, 5. So we get 5 for this and 1 of that. Okay, so with that combination of all the different positions, the different combinations I should be saying, there's going to be a lot to play with running accessories. So I'll be able to run from that one, or the small pulley, this one and the small pulley, and the larger position, the smaller position of that one. So in use, I should get lots of options. I'm really happy the way this turned out, and I'll be looking forward to giving it a go. Hope you enjoyed that little explanation.